Guys, welcome to this videos. Today we are going to be building glaucoma detection models using using convolution neural network. And this is our data sets. You can see this is the data set. I will give the link of this data set so it has some fundus images I will show the images it has glaucoma negative. I think is a 386 file and 134 positives. I think we have pretty less data as to train our model, and see the CSV file which contain the information. I think which image it contain the image name and the labels and three other parameters. These are the database datasets overviews. Mm, then first of all, I'm just reading this CSV file. I'm reading and storing in this train level, and what I'm doing is I'm just taking the glaucoma part. I'll show you. What I'm doing here is just storing into train level variables in this data frame, converting the CSV file into data frame, and just I'm taking white train. White train means dependent variables. So I'm taking this this part this on this columns in this column or series in y underscore train, and I'm printing the some head. I think topmost part of this CSV file, and this is I'm just doing some image processing. I'm importing image data generators, and I'm just defining the directories in this directory. I think glaucoma negative. So I'm just giving train directory and validation directory. You can see here. It's the train directory I've given and the validation directory I have given here. And just I'm defining this directory and just importing image generators. Yeah, I have just deleted it again. Just comment it out because I have already imported here. I'm just importing this in a TensorFlow, and I'm gonna be using the ResNet model. So this I'm using ResNet 50 in the preprocess inputs, and I'm importing method generator, and from keras dot layers I'm importing dense layers and activations, flatten layer, dropout, and I'm from importing models like sequential model and model, and I'm importing optimizers like Adam and SCDs, and from callbacks, keras callbacks, I'm importing TensorBoard. I'm importing matplotlib, as PLT. I've defined the image dimensions, height and width, and I have given this is the class list, isn't it? We have glaucoma negative and glaucoma positive. I've just given this just define these lists in list. We will be gonna be using this list for this, isn't it? And I defined some hyperparameter. I think this is the number of node in dense layer, isn't it? Dense layer, and I have given the dropouts. That's I'm initializing some values, isn't it? Which I will be gonna be using later on, isn't it? Just I'm defining the number of epochs and defining the batch size, and I'm just creating this function as which will take the base model and drop out functional functional layers. I think EFC underscore layers and number of classes, and I'm just creating this function which I will explain you later on, isn't it? These are parameters. First we'll understand these parameters, isn't it? We have given the four parameters to this function. This is our build underscore model function. It needs four parameters. Let's first of all, isn't it, going into the function. Before that, I will just understand the parameters, isn't it? First of all, isn't it, let's understand the parameters. And this function is just returning the model, isn't it? The model, isn't it? We are creating this function. What this function is doing, isn't it? It's just taking some four parameters and just returning our model, returning the fine-tuned model, isn't it? I will explain you later on this in the detail of the functions. Then after that, just understand some parameters. This is I'm just doing for this is what I'm doing data augmentation. It's rotating, flipping, is vertically and horizontally, and width shift range of 0.2, zoom range, for training data set, we have pretty less data, and so image augmentation can solve the problem of less data that we have and I'm doing I'm doing for test generator, but I'm not flipping it vertically because we are predicting, not we are training the model, so it's not necessary to flip vertically. We can just test it our model from horizontal flip and rotation of 90 degree, but not vertical flip is not necessary. And from here I'm just giving that directory path is in train directory this path trend AI I'm giving path, and I'm giving this validation part. Test DR means is this path. I'm giving this path, the this path, isn't it? This path, and I have given the target size and batch size for both. And target size means height and width 300 isn't it? So mm, let's I think first of all let's understand the parameters. I think this is the base model one. We doesn't have this parameter. We have already defined this parameter above Kusini. As I explained you earlier, since we have given this parameter as 0.5 and we have given this list, isn't it? We have already defined these parameters, and class list also I have defined there. We have to just build these parameters and for the function, the build model function is which we have defined above. Isn't it? So this is the best model one parameters, and I'm just giving the base. I think I'm just giving base. I will show you what the base means. Let's wait. I will show you. And this is what I'm defining here as con base is this is I'm just passing the base model means. Base model means I'm not including this top as any. I'm not including this top here as you can see. I'm just defining this resonant 50s. In resonant 50 means resonant 50s. I'm just defining this model as any. This model is resonate 50 isn't it? Or you can just understand by this isn't it? This is BG 16, but I will use this example because it's pretty easy for you to understand then this because this is a pretty good image isn't it? It's a good diagram to understand you isn't it? So this is the con base isn't it? And the BG 16 like resonate 50 also have same like this, but there are more convolution in each block. There are more convolutions. There is only three, I think. There are more convolutions, and this is the base convolution base model. What you define is this is the base. This is from here to here isn't it? Here to here isn't it? Here to here, from here to here, this is the convolution base and this is from here, this is a convolution base, and isn't it, we are just this is convolution base. What we are doing here, we are just creating this, taking the this base, so we are including top as false isn't it? This part is top wasn't this part is top, so we are not including this part is top, we are not including that, but we are just taking this, we have defined include top as false isn't it? So this means that, and giving the input shape isn't it, of 300 comma 3 3 isn't it? And I am using the weights because it's a pre-trained model isn't it? I am using transfer learning isn't it? It has been trained on ImageNet datasets and so during the learning of through in ImageNet data it has gained some weights. I'm using that weights in which it has learned during the training on ImageNet datasets. So I'm using that weights, and I'm calling this function which I've defined here is in define where I've defined that from here. I'm calling this function I'm calling this function which I will define here is this dual model functions, and passing the parameter or arguments parameters yes. And what I'm doing here, where I'm passing it, yeah, this is I'm calling this function and it will return the fine-tune model listening. I will also explain what is fine-tune means, and in transfer learning is you have feature extraction and feature extraction, and you have fine-tuning listening. I will explain the distinction between just feature extraction using transfer learning and listening fine tuning using transfer learning is I will explain this in what fine tuning actually means and why when we have to apply fine tuning is so and when we have to apply feature extraction only is from transfer learnings. I'll explain. I'm just passing this base model one as base model is it will just include this base in this base. It will just include this base I'm passing this base and I'm passing this dropout funcs fc or clear, and this is it just defines as a list which say that in hidden layers in dense layer it has list and we have 100 and something and 124 and some 64 I think we have defined here for layers it will just list of numbers I think which list of number which say that the number of neurons in dense layers after this top part isn't it, and I'm just passing the length of class list and you can and we have called that function and this will return that value isn't it? So let's see isn't it? Let's go to the function we have called the function where that we have passed these parameters and we have go to the function isn't it? It will take this we have already passed from below us in a function call as any first of all we are making the base model underscore trainable as true as any we say that as any we will train this part as any we say that base we have set the base model underscore trainable as true as any true, so it will also learn these words not only this but this also is we will say that as true as any but we will not make trainable to all the blocks. We will just train some of these convolution blocks only I will give some distinction about feature extraction. If you are doing if you are just freezing this whole base as in base and just using your own dense layer and output layer it is we if you define this only this is feature extraction. You are not changing, you are not training these words, you're not retaining these words. This is mean feature extraction. Feature extraction it's usually done when the this model is trained on similar data sets, similar data. I think it is trained on some general specific thing in that we encounter in daily lives, like some tables and some which we really encounter in daily lives, like foods. So I think it's a pretty different things. So it is not good to apply feature extraction. Feature extraction means we are just freezing this base, isn't it? Freezing this, we are not retraining this base, isn't it? We are using the words which it has learned already in from these data, isn't it? From this data, isn't it? Which is available in ImageNet dataset, isn't it? So, isn't it? This is our we are doing eye classification, isn't it? Eye classification, which is not related to the objects that we deal in real life, isn't it? Like shoes, pants. I think this have some common classes. I think 100 classes, 1,000 classes. I think 1,000 classes. It has which is not which is pretty different categories. And so we are applying fine tuning means we are not only just not freezing this whole, but we are also opening this. We're also training these twos in it two blocks, two blocks or one block. This is called fine tuning. And we have from here to here. This our model is freezes. We are not training from here to here, and we are just training from here to here. We are training our models so we have to train this from here to here and because we have pretty different data then which it has learned like general categories we have pretty specific things so we have to use fine tuning not the feature extraction process. And what I'm doing here is from this loop is just I'm setting which layers are trainable or which layers are not trainable and I'm defining the variable set trainable is equal to false. Then I'm just defining this variable and I'm just going for base underscore model dot layers and layers. First of all, we have the layer dot name. If you encounter this convolution fourth block, we are setting that our setting trainable as true, isn't it? And if this is true is in our trainable layer the trainable is equal to also true is in else the trainable is equal to false isn't it? What I'm doing here is just after when we encounter this block or this convolution block means this block doesn't it? This block, when we encounter this block, we will start our training, isn't it? We'll start our training process. So if I am setting training, if when I encounter this, I will make this set trainable is equal to true, and it will make the layers, that layer trainable is equal to true, else it will not be trainable as in trainable as in just I am printing the layers, and layers dot name, and I'm also defining is it trainable or not, layer dot underscore trainable. I am just defining is it trainable or not, just we are just seeing the layers and just trainable or not. So I'm printing it for our purpose. And I am given x, I'm defining the base model dot output. Base model means this convolution base model, this base is equal to, I'm defining storing in x, and I am flattening the output of this base model, isn't it? Output I'm just flattening, isn't it? Flattening of x. And what I am doing in this loop is I'm creating, we have three numbers, I think in f underscore layers we have three numbers in 124, 64, and something another numbers. We have three numbers. So first of all, it will create a dense layer of 124 with activation values, and it will give a x, and which we have given this pattern x here, isn't it? And after that we will add a dropout, and we will take this input as here from here is here, and it will do predictions of, we are this is the output layer. So we are using number of classes, and we have two classes. I'm using activation as sigmoids, and this will give this x as input. So this is last layer, last output layer. So we are doing prediction here, number of classes, activation is sigmoid, and passing this x. Still do prediction and fine tune. I'm fine tuning. I'm just using just defining the variable fine tune model, and I'm giving the name, giving the model as input. What's the input? Its input is base model dot inputs. This model input is this base model dot inputs, and output is prediction, because this is our output layer. So I'm passing the output as predictions, and input as base model underscore inputs, and I'm returning this variables in your this class, not a variable, this class class objects. So I'm returning this, and I'm getting this when I've called the function, isn't it? What I'm getting there's I'm getting is this model. I'm getting our model is ready, isn't it? So we can use it, and I will see using this. Look at here, from when you encounter, isn't it? When you encounter the block 4, isn't it? Block 4, I am training, I'm just setting this block training, from this layer we are training from convolution block 4, convolution fourth, we are just training our, I'm just, you can see the train layer dot trainable is equal to true, and up to before, on top of, I think 2 3 layers, I have 2 3 layers I have set trainable is equal to false. So from, as we encounter convolution 4, I'm just training there's this block and this fourth and fifth block. So, and this is a node, I 124 node, 512 node, 256 node, and this is a dense layer, which we have created, and just I'm compiling the model, using optimizer Adam loss binary cross entropy. I am using the matrix accuracy, and I am using callbacks like model checkpoints or stoppings, and I have big more this model checkpoint. What does it does? It's a callback, which will save the best model, which it will save the model, which we have train. It will save the model according to the best weights, which are best weights, and I'm giving the path where this weights values, will be stored, it will store on this directory, kaggle as working, and we are getting this file, model.weights.s5, we are getting this file, and I am using orally stoppings here, you can see. This is the orally stopping. This is also another callback, is from it will just stop it. What does it do is it will stop when our model start start training is start does not. It will just if our model get stagnant on training is it will just stop our training process and it will terminate our training process. If our training process does not improve or our training process has learned as any, then training process is completed, it will just say that said us your training is enough as any. So I'm monitoring validation losses any. If validation loss does not as any, does not changing as much or decreasing as much as any, it will say it will just stop our model as any. It will just stop our training process. I'm using passion at 20 means it will observe, it will wait for 5 listening before stopping. It will wait for 5. I'm giving patient as 5 means it will stop until for 5 epochs listening, to observe listening to stop the training process or not. It will wait for 5 epochs, and I'm giving verbose as 1. I'm just restoring the best words, and this is a callback list isn't it? Early stopping and model checkpoint, and I'm printing the class indices. Whatever glaucoma negative as 0 and glaucoma positive as 1, and I'm just printing the summaries in it. This is our summaries in it. This is our ResNet model in it, which I've used. It has many parameters in it, a total of 233 million parameters. About some I think 232 is in it. 232 million parameters are trainable. It's pretty huge parameters isn't it? Pretty huge. We have to find the optimal values for each parameters according to get our model to perform better and better. This is the our after training process and it will learn these values of these parameters and it include weight biases and weight biases. Yeah, it will include the weight and biases values and some optimizer parameters also I have seen in some cases. And you can see how many it's pretty huge number. So it's an MB isn't it? Nearly half a G, more than half of GB isn't it? Renewable parameters, and I'm just fitting that model with trained generator as a number of epochs I've given as any. Feed generator is good, but I think it's depreciated. It doesn't work. On my case, it is depreciated, so I'm just applying more resnet more underscore model dot fit isn't, and passing train generator number of epochs. I'm shuffling isn't, and I'm passing the validation data as test generator isn't, and I'm passing callbacks isn't, and I'm fitting to the model listening, which will it will learn from this data, and we're in certain epochs. It will validate also. So I've given the validation data, it will also validate, and it will give the logs and logs. You think what's model learn and just give the learning history, isn't it? And I'm storing this in a history variable. So and our model training start here from here, isn't it? After a 15 epochs and we have gone to up to the accuracy of 72%, doesn't it? And validation accuracy 73% in spite having pretty less data. I think it's pretty pretty less data. We have pretty less data, and we have gone in such a classification. I think it's a pretty difficult task. It's not that easy, like because it's the image class eye disease classification. It's if you have good amount of data and some better fine tuning and hyperparameter tuning, you can reach even better than that. But it's a good. I think 72 is not so bad, but it's good. You can. There is a room also for if you increase the data and if you increase the. I think this is I am just doing for 15 epochs. After some tuning your models, you can even run for more epochs, and I think it's getting the best weight at epoch at the end of epoxy, and this will be stored this is restoring the model weights from the end of the best epoxy 11. I have defined the model checkpoint as a model checkpoint, so it will restore the best weights and best weight, and it will save here as save here. You can see here this is the best weight, isn't it? About 2.8 GB, and it's pretty large file, isn't it? From end of the epochs we upgrade the accuracy of best accuracy of epochs 11. Where is epochs 11? epoxy 11 is here, isn't it? We have gained to accuracy of 70% and 7 validation accuracy of 73%, isn't it? 73. And this is our best model, I think. 11 from at the end of the best epoxy 11. 11, 11, 11 means this is I think 11 epochs. And this is 11 epochs and 70 means 70. Why is it should it's a minimum loss, I think. At the end of 11 we have 70% epoxy 11. We have why is restoring it that giving it is restoring the best model words at the end of the epoxy 11, isn't it? I think it has less validation accuracy, I think. So it is not showing here, but I think it has other accuracy metrics. So it will restoring that best model words. Not only the 70%, but also validation accuracy maybe. But it's not showing here and some other accuracy metrics. It is also considering, I think, not only this accuracy and other, but it's also considering the validation and other accuracy parameters and other precision parameters. So I'm just evaluating the model, isn't it? I'm doing a model evaluation, just seeing what the model have learned and just some doing some prediction. I'm just using importing some matplotlib, cbon and opencv module, isn't it? And just you can see I'm just taking the accuracy, I'm storing this in accuracy variable and from history dot stories, which this is the log, isn't it? It will contain all the history of models, and so I'm just history dot history. I'm taking values and accuracy, and I'm just getting the length of from the length of accuracy, and I'm getting the from range of length of accuracy. I'm getting the epochs, and I'm plotting, isn't it? And I'm plotting, isn't it? Plotting my model, isn't it? This is I'm plt dot plot epochs accuracy r training accuracy plot, isn't it? Epochs validation accuracy, and this is our, isn't it? I think x-axis is our epochs and y-axis our accuracy, and same for some validation accuracy, isn't it? It's a red and I think it's blue, isn't it? I'm giving red as R for training, this in training accuracy, and D for blue for validation accuracy, and just I'm locating in upper left, in upper left this bar training accuracy and validation accuracy, and so from this scope I think our validation accuracy validation accuracy has actually decreased. I think training accuracy has gone pretty high, but our validation accuracy has decreased, isn't it? Decrease at the end as it's not good, isn't it? So we have to do some tuning, and I will do in my notebook. So oh, this is not good, isn't it? So it's decreasing, isn't it? It should be also our accuracy, validation accuracy has been stagnant, isn't it? And decrease here, isn't it? But there is not much gap between the our training accuracy has been gone up, isn't it? It's a good thing, isn't it? This is maybe I think we are validating our validation accuracy. Why it has gone low? It may be our network architectures and network architecture we are using. We are also we are predicting right, and I think it has been overfitting also, isn't it? Because our we have very much parameters. I think it has been overfitting, maybe overfitting. Overfitting we can reduce overfitting from several techniques. And I'm just plotting loss. I mean, loss has been pretty good. As in, this is validation loss has gone so good. This and training loss also has been good loss. And this is there is no overfitting in loss, and there is something we have to work on accuracy metrics. So we have to care on this. And I'm doing prediction. I'm just taking some images from this file which I have not used it. This I'm just using from images from here, and I don't know what this images is, but you can take the images and just check your give the path of the images and check it listening. And I am reading what I'm just defining the image path, and I'm reading the images from this image path listening image path, and I'm storing at image variable, and I'm resizing the images in of 300. This is a pretty I think we have not defined the size, and it can be any size, and so I'm just making the size of 300 height and width, and resizing it and converting into arrays in numpy arrays for for the model and I'm just printing the shape and it is 300 comma 300 comma 300 and I'm reshaping it because I have added new extra dimension because this define I think we are giving one images at a time it will also we need also that dimension we are not training in batches so I think we have just giving one images so we have to also add this one dimensions before sending to the model because we have given some batches of images so train our images from this batch this is define the batches it say that we are giving the one images at time that is it is saying rather than it's pretty way to understand easy to understand we are sending one image at a time and this is our whole tensor we are propagating through the model and just this is our shape and I'm just printing which images I have taken this is the images what I have taken this from the path these are retinal images which I have which somebody has captured it this is we am taking the retinal images and I'm just I'm just importing image and I'm just loading images and storing in this variable and I'm showing these images I'm showing the images and I'm plotting the images you can just axis is equal you can just axis is equal to off better this will just read out my axis is not off we have to do with this that's fine it's working isn't it just remove the axis isn't it which is not needed in our case isn't it it's giving output as zeros and zero I will show you that we have to define the class list as so class underscore list is an list that is setting a class list sub indices this is the glaucoma affected isn't it glaucoma affected images our model is telling that if this image is being affected by glaucoma isn't it so you can try you can just take some of that affected images and you can try on your own is your model is predicting good or not you can just check it and that's it for this video and I have given the this notebook link at the description you can just go through the each cell and do some your own experiments with this notebook to concretize your learnings and just go through the notebook and make some improvements which need to be made in this notebook. I have just given the basic layout and you can add more things so go go to the notebook and do some improvisation and on your own which will develop your learning process